Everyone, welcome to our class for today. In today's class, we are going to consider logarithm and standard form. We are starting a bit late, but no problem. We're going to catch up. From today's class, we're going to look at logarithm, and you're going to learn how to solve problems in different bases. And after that, we are going to see how we solve questions in your JAMB UTME exams, questions related to JAMB UTME exams under logarithm and standard form. And at the end, you should be able to also establish the relationship between indices and logarithm when solving problems involving logarithm and indices. So we are going to look at this very well and then see how we will come to a point where we can easily be able to answer some other questions. Now let's look at some few things we're going to consider under logarithm. Then we'll look at some laws of logarithm that will be very, very important for you as you sit for your examination, the JAMB UTME exams. First of all, when we talk about logarithm, we're going to look at in order to yield a given number. Now, when we express 3 in 81, yield a given result. And what will that exponent be? Remember, 3 to the power of 4 is equal to 81. So what will that be? That is now going to give us log of 81 to base 3 will be equal to 4. So you see, that is exactly what I'm trying to bring to your mind. So the log of 81 base 3 will be equal to 4, because if you consider that, you see 3 in what? We find that an exponent of 4 is needed in order to make 3 in 81 yield to what? Yield a certain what? A certain number. So a 3 to base 4, I want you to understand this, that an exponent of 4 is needed in order to make 3 in 81 to be what? To be possible. So that means 3 to the power of 4 is equal to 81. So if we take the log of this as it is, remember, if we want to return this to log, this is going to give us the log of 3 81 to base 3 equal to 4, considering what? This. So logarithm has to do with what? With the exponent of power, or power which a number can be raised to in order to yield a certain what? A certain number or product. And that is exactly what the mind you should have when you look at logarithm, when it has to do with what? With its various formula. Now, the question is, let's consider some keynotes and consider some key formulas in logarithm that can help us see what we really want to understand as regard this. As you sit for your JAMB UTME exams, you will be tested on some of these laws of logarithm, which we are going to discuss about. So let me flash your mind back to, this is just an introduction to logarithm. Now let's flash your mind back to some of the laws of logarithm you should be familiar to as you sit for your UTME, JAMB UTME exams. The first one you should be familiar with is the product rule. Now, what is it about the product rule in log? When you have the log of m multiplied by n to base a, according to the product rule, this will be the log of n to base a plus the log of n to base what? To base a. So product gives you what? Yields what? Addition when it comes to logarithm. One thing about logarithm is they have similar laws with indices. That's why I say we're going to look at how you can consider logarithm and questions under what? Under indices. Now, that is the product rule. Now, let's look at number 2. We're going to look at the quotient rule. Now, what is it about the quotient rule? If I have log of n divided by n to base a, this will be equal to the log of n to base a minus the log of n to base what? To base a. Now, if you understand the introduction I gave you on logarithm, then you should be able to start flashing your mind to this product, that laws to these rules. Logarithm has to do with product, exponent, and the what? And the base, yielding a product. Now, let's consider what we call the power what? The power rule. In the power rule, if you have, we call this the power rule. In the power rule, if you have the log of m to the power of p all in base a, when it has to do with power rule, this will be equal to p multiplied by the log of n to base what? To base a. And that is exactly what that logarithm is going to give you. So that means the exponent or the index is going to multiply the log of that value to its what? To its base. Now take note of that. There's another rule we call the logarithm root. The logarithm root, that is the logarithm of the nth root of a number, is the logarithm of the number divided by what? By n. And that is what we call the logarithm root. Now, what do we mean by that? We call that the logarithm root. Now, when we have a given log like this, the log of, if you have a log like this, the nth root of m to base what? To base a. Now, how do you play around with this? This is what we call the logarithm root. Now, if you are given this, do you know that this can be equal to the log of n to base a divided by n? And that is what we call the logarithm root. Why? Why do I say this? Because this can simply give me a log of n to the power of 1 divided by n to base a. And you know this will definitely come here. And this will give you 1 divided by n, the log of m to base what? A. And if you simplify this, you definitely have the log of m to base a divided by n. So you see, this is what we call the logarithm what? Root. So when you are given this kind of equation or logarithm of this form, that is the rule under the logarithm root. You can easily simplify that to get your answer. And now that is that. Now let's consider another law or another rule in logarithm, which now, in that rule in logarithm, if we are given rule 5, in this rule 5, we are going to call this rule the logarithm base change rule. Now, what does that tell us? If we have the log of, if we are given the log of x base b, the log of x base b can be equal to, we call this the logarithm base rule. Log of x base b can be equal to the log of x base c divided by the log of x base what? Base b. Now, do you see that? That's exactly what this, no, I didn't get this rule well. we are going to look at this rule. We call it the logarithm-based change rule. And what do we have? That we have the logarithm-based change rule. Now, it is a logarithm. Let me explain it better for you, because we are going to look at the change in what? In base. Now, if you have the log of x base c divided by the log of b base c, we are simply changing base because we have a common base. Now, if you look at this log very well, you come to see that we have a common base, c and c. So we'll call it the log of what? Change of base, because this will become the base and this will become the what? The exponent. So this will typically give us the log of x base what? Base b. So it's better I start from here to this point so that you can have a better understanding of what I'm trying to say. Now, if you have a log in which you have the same base, that means you can have this what? You can apply this log base change. We call it the log base change, the log base change rule. So you can apply this rule in order to get a solution. Now, if you have a question like this, let me show you a typical example of where this works. If you have the log of 10 base 3 divided by the log of 8 base 10, log of 3 base 10 equal to log of 8 base 10. This can be equal to the log of 3 base what? Base 8. That is what that log simply tells us. And that is what we call the log base change. So that means we can change the base of that logarithm in order to have what? In order to have the solution to that question. So we call it the logarithm-based change rule. Now take note of that rule. It's very important when we solve questions on that logarithm. Now, JAMB is going to test your knowledge on these rules because they know that if you can play around with these rules, then you can be able to solve typical questions on that logarithm. Now, let's look at the logarithm-based switch rule, or we call it the reciprocal rule. Now, what is it about the reciprocal rule? That's rule 6. We call it the reciprocal rule. Now, what is it about this rule? Now, in this rule, if we have a given log like log of m base a, we can interchange the base and the logarithm when we take the reciprocal of it. And this will now give us the log of a base what? Base m. That is what we typically call the what? The reciprocal rule, or the switch. We call it the logarithm based switch rule. We call it the logarithm based switch what? Rule. So you see that if we have the log of, like if we have the log of 3 base 10, this can simply give us 1 divided by the log of 10 base what? 10 base 3. And that is what we call the logarithm-based switch rule, or we call it the reciprocal rule. So that means the base can become the log, and the log will become the base once we do reciprocating. And that is that. So that is another rule in logarithm. We want to also consider another law, that's rule 7. In this rule is very typical, but most of the time people don't look at it. That's rule 7. We call it the logarithm zero rule. And what is this rule about? Logarithm zero rule says if you have the log of 1 base a is equal to 0. So that means if I have the log of 1 base 2, this will be equal to 0. That means if I have the log of 1 base 10, this is going to give me what? 0. Now take note of this, it's very, very important. When we have any log at any base, as long as the log is 1, the log of 1 is equal to what? 0. That means the log of 1 to any base is equal to what? 0. So we call it the logarithm 0 rule. Log of 1 to any base is what? Is 0. Now finally, this is a popular law of logarithm. Base raised to power law. We call it base raised to what? We call it base raised to power. If we have log of a to the power of a, we know that that is what? 1. So if we have the log of 10 base 10, that will be equal to 1. So that is a popular law of logarithm that we all need to know. So the key laws of logarithm I want you to seriously take note about is 5, 6, and what? 7. They are very, very important. You don't play with them. We have 5, 6, and 7. 4 is also important, the logarithm root, but that one you can easily play about it around it because you can easily remember them. But this reciprocal rule is very important that whenever a log changes with its base, it can be reciprocated in order for the base to become the log, and the log can become the base. Now, these are some of those rules we need to play around when we deal with what? With logarithm. Now, without wasting much time, let's take some few questions on that logarithm before we will now discuss on indices. I want to bear in mind that you now understand these few laws I've highlighted, because what JAMB will do is to test your knowledge on the use of these words, on the use of these laws of logarithm. Now, I want us to look at one question. We're going to look at this question. The question says, this is a JAMB UTME question, sample 1. The question says, if log 4 base 10 is equal to, if log 4 base 10 is equal to 0 0.621, you are asked to evaluate log 4 to the power of 1 divided by 3 is 10. Now imagine this question. You are told to evaluate the log of 4 to the power of 1 divided by 3 base 10. Now, I want you to remember the laws of logarithm we talked about. Do you recall rule 4? In rule 4, if you have the log of nth root of m to base a, you recall that this will be equal to the log of m to the power of 1 divided by 2 to base a. That's exactly what you have here. So if you look at that logarithm very well, you'll come to see that this whole thing can be written as log of cube root of 4 to base what? To base 10. And remember that the question says log of 4 to base 10 is equal to 6021. So how do we isolate that? I want you to look at that very well. Now, if you look at this very well, we can still take it back to what we have as log of 4 base 10 divided by 3. That's rule 4. that says if you have a log like this, remember under this log, this will now give us 1 divided by n log of what? M is what? Is A. And if you simplify this, this will definitely give us log of what? M is A divided by M. So this will definitely give us something like this. So a very simple question. But if you don't know the rules of logarithm, you'll find it very, very difficult. Remember, log of 4 to base 10 is this. So this will simply give us 0.6021 divided by 3. Now, if you divide that by 3, you are simply going to get the answer to your question. So if we divide that by 3, this will give us 0. This is going to give us 2,0,0,0, and that will be your solution. So if you check the options in your exams, in your question, you're going to see this. Now remember, this is going to be a computer-based test exam. So all you need to do is you have your plain paper ready. So once you see this question on the screen, quickly apply the laws of logarithm we've enumerated in these videos, and then use it to what? To analyze the solution to that question. Then your answer will pop out. Now let's look at another question that will entails us applying one other law of logarithm. And this question is not going to be difficult, but it's one of those questions that's selected from your JAMB past question series of questions. Now, in that question, we are given that if, that's question sample 2, if the log of x squared to base 3 is equal to, we are told that if this log is equal to -8, you are asked to do what? What is x? If the log of x to the power of 2 base 3 is equal to -8, what is the value of x? Now, assume you are given this kind of question, how can you find the value of x? You need to apply the laws of logarithm. From those laws of logarithm I've given to you, you remember one law we stated earlier on, that if you have, remember this when we introduced the law of logarithm, that if you have the log of x base a equal to n, then the value of our x will be equal to a to the power of n, because this will just come here and take this to become a power. Now, if you remember that rule, then this question will be very easy for you to manipulate. Now, the value of x will be very simple. Now, if we apply that law here, you know that x to the power of 2 is a single value. So that means our x to the power of 2, right, can be equal to 3 to the power of -8. And that is all. So if you can manipulate that, you can see that you find your answer. Now, for you to find the solution, you know that you must have to do what? To take the square root of both sides. Do you realize that if we take the square root of both sides, this will give us x what? Square equal to 3 to the power of -8. The square root, which is plus or minus, depending if you have it such in your answer, because it's a square root. If this clears this, then our x will be equal to, because of the square root, we have this as plus or minus 3 to the power of -8 multiplied by 1 divided by 2. Now recall that the square root is, if you have the square root of n, this can be equal to n to the power of 1 divided by 2, right? So if you do that, you can simply cut this 1, and this will give us what? 4. So the value of our x will be equal to plus or minus 3 to the power of -4. Now remember, according to the law of indices, if you have this will be equal to 1 divided, because the negative is just like a reciprocal, 1 divided by 3 to the power of 4. So your x will be equal to 1 divided by 3 to the power of 4 is 3 times 3, 9. 9 times 3, 27. 27 times 3 is going to give us what? 81. So we're going to have this to become 81. So the solution will either be plus or minus 81 if given, or naturally it can be what? 81. So you see, solving questions like this can be very easy as long as you can apply the laws of what? The laws of logarithms. Now, try as much as you can to have in your memory those laws of logarithm we have highlighted earlier on. Now, there is one typical of this question that used to come out in JAMB, and I want you also to discuss it. Let's look at sample 3. Now, let's consider this sample 3. Your exams used to come out in this format. Sample 3, you can be given this kind of question, given that log 2 is equal to 0.3010, log 7 is equal to 0.8451. You are asked to evaluate log 112. Now look at that question very well. You are asked to evaluate log 112. Now you have to do a lot of factorization in this instance. Get your solution to this question. So we have to play around with a lot of factorization in this regard. Now, how do we play around with 112? Now we have to look for the factors of 112 such that 7 and 2 can easily come out. Now, when we consider the factors of 112, the factors of 112 can easily give us 16 multiplied by 7. 16 multiplied by 7 can give us 112, right? Good. And 16 can easily be reduced. This 16 can easily be reduced because 2 to the power of 4 can be equal to 16, and then we already have 7 here. So that means we can still use this because we have the base of 2, and then we can use this because we have a value of log 7 and this. So that simply tells us that a log of 112 can be equal to the log of 16 multiplied by 7. I remember the rule of the product rule of logarithm. This will now give us the log of 16 plus the log of what? 7. So this is going to give us the log of 2 to the power of 4 plus the log of 7. Now, according to still the law of logarithm, this is going to multiply this log of 2 plus log of what? Log of 7. So we already have the value for log of 2 as we'll have this to multiply 0.3010, right? Plus the log of 7 is 0.8451. So if you multiply 4 by this, we're going to have that solution to now give us 4 times this will now give us, what is that going to give us? If we multiply that, let's see if we'll use a calculator in order to get an accurate value. 4 times 0 is, that will give us 1.2, 041. Now, if you point that, I want you to point your calculator if you are watching that, and that will give us 1.2041, right? Now, we're going to add that to 0.8451. So let's sum this. If we sum this, we are going to have this to become, this is going to give us 2, this is going to give us 9, this is going to give us 4, this is going to give us 10, and then this is going to give us 2.049 what? 92, right? And that is exactly what we are going to have. So the solution of log 112 is equal to 2.04992. Now, if you are pointing your calculator, I want you to point your calculator to find out if this solution is actually right. If it is right, that's exactly the kind of question you are going to see. So since it's going to be a CBT exam question, this is a similar of the kind of question you are going to see. So as long as you know the product law of logarithm, you can easily manipulate your way in finding answer to this question. Now remember, in your JAMB mathematics, you're just going to be given 40 questions. And each of these questions, you're not meant to spend up to 20 seconds is even much for a question. 5 seconds in one question, you are done, because you'll be given a short amount of time to answer this question. Now, that is that. Now, let's look at the final question. If you are just joining us, we've taken 3 sample questions, and now we're going to just consider one final question. And that final question is on a question that is similar to this. Now, let's look at that final question before we now consider the standard form. And this is going to give us, this is going to be sample 4. Now, let's consider sample 4. In sample 4, we are going to look at a typical question, and they say if log 7.5, this has to do with decimal, is equal to 0.8751. You are asked to evaluate 2 log 75 plus log 750. Now, I want you to look at this question very, very well. If you are giving this question in JAMB, it's a very easy question. How do you play around with this question? Because this is typical of JAMB question. I want you to look at your series of JAMB past question. I will have to bring a list of JAMB past question I have for mathematics. Maybe I'll put it in my website and then drop the link in each of these videos. Go through those questions, look at questions on logarithms and standard form that we'll look at the ones you can solve. These are typical of JAMB past questions. Look at them, practice them, and see how you can solve questions like this. Now, if you are given a question like this, how do you go about solving questions like this? Now, remember, you are told that 7.5 is equal to 0.8751. You're asked to evaluate 2 log 75 plus log 750. Now, there are 2 things you must note. That this 7.5 multiplied by 10 is exactly what will give us 75, right? That is clear. If you multiply 7.5 times 10, you get 75. Now, if we multiply 7.5 times 100, we're going to have 750, right? That is clear. So how do we manipulate it in such a way that we can be able to arrive at a solution? Now remember, the only thing we are giving is 7.5 equal to this. Now we are going to play around with that figure. Now from here, we have 2 log. We're going to replace it with what? Log, and we are going to make it in base 10, because if you don't have any base here, it simply tells you that all these are in base what? 10. If you don't have any base here, it simply tells you that the logarithm is in base what? Is in base 10. So what do we do here? We have log of, this is 75 is going to be replaced with 7.5 multiplied by 10, right? And that will be plus log of, this is going to give us 7.5 multiplied by 100. Now remember the rules of logarithm, the product law of logarithm. If you haven't joined us when we discuss the laws, you can have a replay of this video, and then you look at the series of laws we discussed under logarithm. Now, that law permits us to separate this, right? So if it permits us to separate this, we can separate it. So we'll have to write the log of 7.5 to base 10 plus the log of 10 to base what? To base 10. And that is gone. And this will be plus log of 7.5 to base 10 plus the log of 100 to base what? To base 10. So you see how we are breaking it down little by little. Now we already know what log of 7.5 to base 7.5 is. Remember, this is to base 10. I told you if you are not giving any base to any logarithm, it is assumed that it is in base what? In base 10. So we are going to have this, we have this, we have this, and we can simplify this because 10 to the power of 2 is 100, right? So will have this to be 2 multiplied by 0.8751 plus, remember that law of logarithm we stated earlier on. If you have the log of a to base a is equal to what? 1. So if we have the log of 10 to base 10 is equal to what? 1. So this is simply going to give us what? 1 plus, we now have this to become 0.8751 plus. Now let's play around with this. This is going to give us log of 10 to the power of 2 is what? Is 10. Now, according to the law of logarithm, this will give us log of 10 to base what? To base 10. And log of 10 to base 10 is just 1. So we'll have this to be what? 2 multiplied by 1, which is equal to 2. So what we'll have here simply is just what? Is just 2. So if we go ahead to do this, we're going to add this to this, and this will give us 2 multiplied by this plus this is going to give us 0.8751 plus 1. What is it going to give us? If you add that, it's going to give us a solution. I want you to add it, and once you add it, you multiply it by what? By 2. If you add it, you're going to have 1.8751, right? Then we'll now add this to this, and if you add that to that, we are going to have that to now give us 2.8751. So if we multiply this and this, we are going to have the solution. I want someone to multiply this. If we multiply that, we're going to have that to now give us 3.7502 plus 2.8751. So if you add these two, we definitely have a solution to that question that's given to us. So when you add those two parameters, what do we have? We're now going to have the solution to become finally 6 points. That will give us 6 points, 6 to 5 what? 5, 3. And that would be the solution to this question you are asked to evaluate. It might seem so lengthy, but then this is a typical of JAMB pass question. If you know what you are doing, you're not supposed to take time in solving this question. All you just need to do is to just simplify. Simplify such that you have 7.5 multiplying this. There are other simpler methods you can use in simplifying this, because 7.5, I can still have my what? My 75 divided by 10 to give me 7.5. So that means I can have a log of 75 minus log of 10. So there's a way you can do a lot of manipulation. Mathematics is all about you being logical in your what? In your reasoning, and then find how you can find solutions to problem, and that is just it. So this is the final solution we'll be taking on logarithm. So where we'll be heading to now, we are going to look at standard what? Standard form. Because I promise you guys, we're going to touch logarithm and standard form together, and then we are going to just look at some few questions under logarithms and what? Standard form. If you miss this class, there's no problem. You will always find the replay of this class in videos down in the live section of my channel. Now that is that. Now I want to drop you guys just 2 questions or 3 questions I want you to look at if you can practice them. It's going to be under logarithm. I want you to try these 2 questions. If you can do this, then drop your answer. Question under logarithm. 1, I want you, if you are given if log 6 log x squared minus 3 log x3 is equal to 3 log 0.2 to base 5. We are asked to find what? We are asked to find x. Now look at this question thoroughly. If you apply the 4th law of logarithm, you should be able to solve this easily. Now this is going to give you 0.2 is just simply going to give us 2 divided by 10. And from then, we can easily solve this. So look at this question thoroughly. I have them already solved in the series of JAMB textbook I have. And you can look at the solution and see how you can find a solution to this. These are typical of JAMB questions you will be asked to find a solution to. Now, I want you to have that. And finally, I want you to look at this question. I want you to look at this question and then see how you can solve it. These are JAMB questions that have common base. You are asked to evaluate log 8 base 2 plus log 16 base 2 minus log 4 base 2. Now look at this, just these 2 questions. If you look at this log, you find out that they all have same base. You can simply simplify them and then you get the solutions to those questions. So try these 2 questions and let's see what you can do. And also I'm going to drop a link to a website where you have series of questions. Okay, someone is saying, can he ask? Yeah, of course, you are free to ask questions. This is a free, it's a class, you are free to ask questions. If you have your question, you can easily ask your question. We'll be free and happy to answer your question. I love that. So feel free to ask your question, and then we'll get a solution to your question. So let's look at how we'll go to the next topic we'll discuss. The next topic is going to be standard form. Let's look at standard form, and then let's see what we can gain from standard form. Now, when we discuss standard form, as we expect your question, someone says they want to ask something. As we expect your question, let's move ahead because I want this class to just be an hour class. Now, let's look at standard form. We're going to look at standard form as a topic, and we're going to look at how these questions are asked or how questions under standard form are asked in your JAMB exam setting. Now, when we talk about standard form, at the end of this discussion, you should be able to carry out operations in standard form. Now, what is standard form, and why is it that most of the time JAMB always asks questions on standard form? Now, when we talk about standard form, we are talking about a method that is used to express very large or smaller numbers into a much simpler term. And that is what standard form is all about. When you have a very large numbers in their millions and billions, standard form can help us express such number in what? In smaller words, in smaller form. And that is exactly what that question. Numbers like, when you have numbers like 237 in their billions, 800,000. When you have this kind of number, it seems too large to be written, but it can be reduced using what? Using standard what? Standard form. What about if you have numbers like 0.000087? This number is so small that it cannot be easily mentioned, but it can be written in standard form. Now, mathematically, standard form can be written in form of A multiplied by 10 to the power of x, where x signifies the positive or the negative what? Integer. This is what? The positive or negative what? Integer of that number, while A is the what? Is the number between 1 and 10 that represents the number that is given to us. These can be numbers between 1 and 10. So if I write this kind of numbers into this form, I've simply done what? I've simply reduced that number into the smaller word, into a smaller term that can be words that can be readable. Now, when dealing with standard form, I want you to note two key points. Now, what we do is we deal with key points here. If you are given numbers, smaller numbers, when you count smaller numbers, counting smaller numbers from the decimal point to the last value to your right will always give you what? Result to a negative integer. Now, what do I mean by that? If you have smaller number and you need to count that smaller number to your right, it will always result to a negative integer because you are gradually reducing the what? The place of the what? Of the zeros. Now let's look at a number like this. And I want to reduce the zeros so that the number can be easily what? Can be easily mentioned. Now I'll be counting from my left to the right. Counting this way will always give me a negative what? A negative integer. Now let me count from here from the decimal point. 1, 2, 3, 4, 5, and what? 6. So that will give me 87 multiplied by 10 to the power of negative what? Negative 6. Because I've moved the decimal point to after what? 7. Now, I can still have this to become 8.7 multiplied by 10 because I'll move this decimal point from here 1, 2, 3, 4, and 5, and that will be raised to the power of negative what? 5. So, depending on the extent to which I move that number, I can make this number much what? Smaller, and can be easily what? Read. This small number can be easily what? Read. Instead of me saying 0.0000, I can just say this is 87 by 10 to the power of minus 6. And that is that. So whenever I count smaller number from the decimal point down to my right, then the integer should be negative. Now for larger numbers, if I count larger numbers from my right and from my right back to the left where we have the decimal point, then we should be looking at having a positive word, a positive integer. Now, how do I mean by that? Now, let me look at this. Let me illustrate with this. Now, if I have this number 17600. Now I want to express this number in standard form. You can be asked to express this number in standard form. Now I have to look at the decimal place where the decimal point will begin and where the decimal point will end, and that will result to a positive what? Integer. Now if I count this, if I want the decimal point to start or stop here, I can simply count from here, from my right to my what? To my left, to the point where I want the decimal point to stop. Now, if I count, wherever I count, determine what the number will be. So if I count from here, 1, 2, and what? 3, that will definitely give me 17 point what? 17.6 times 10 to the power of what? Of 3. Now, if I decide to count from here to this point, this will give me what? 1.776 times 10 to the power of 4. And that is what that is going to give me. So when you are dealing with standard form, this is exactly what we should think of when dealing with standard form. Now, I want us to continue this discussion as we look at some few examples under standard form. Olakunle Jubril Okoyemi say we should solve this problem. 6 raised to the power of, I can't see this very well. 6, what do you say? 6 R base 8 equal to 511 base 9. Can you please send this to any of my medium? Maybe you can drop it in the chat of this video, then I'll pick it up from there. Or make your question very clearer so that we can be able to know what you're asking. Now let's just look at 2 examples on standard form, and then we'll round up this class. Just 2 examples on standard form, and then we'll round up this class. The first example we are going to take is, let's quickly take those 2 examples, and then we can round up this class. We are asked to express sample 1 sample 1 we're asked to express the product zero point zero zero 0.0014 and 0.011 in standard form. So we are asked to express this in standard form. So how do we express this in standard form? Now, if you want to express this in standard form, the first thing you need to do is to convert all values to standard form. And you also note that a product is more of multiplication. You're asked to find the product of these two numbers. So product is all about multiplication. So what we are asked to do there is 0.0014 multiplied by 0.011. And that is just simply what we are asked to do. So what you need to do here is to convert these values to standard form, and then you simplify. Now, if I convert this to standard form, I want to have a 14. So I'll have this 1, 2, 3, and what? 4. So that will give me 14 multiplied by 10 to the power of negative 4 multiplied by, right? Now, this is going to give me 1, 2, 3. That will give me 11 multiplied by 10 to the power of negative 3. So what will this give me? We can simply separate the values and then separate the powers, which is 10 to the power of negative 4 multiplied by 10 to the power of negative. So if we simplify this, 14 times 11 is going to give us what? 14 times 11 is going to give us 154, right? If you multiply those two things, we are going to have 154. And this, according to law of indices, multiplication, the product law, is going to give us negative 4, right? Plus, we're going to have negative what? 3. Now, do you see that? Because we have the product of these same base, the powers or exponents will add. So we'll have this to become 154 multiplied by 10 to the power of negative 4 minus what? 3. And this will be equal to 154 multiplied by 10 to the power of negative 7. So you see, the value we are going to have is going to be in what? In standard what form. Now, if you check your solution very well, you're going to find out that this is in the solution. And if this is not in the solution, then we have to simplify. Now, if you check the solution very well, you find out that 154 times 10 to the power of minus 7 is not in the option. I can see the option here. So what we need to do is to simplify further. I'm going to simplify this because we have 1.54 in the option. So if we move this point 1 and what 2, this will now give us 1.54 multiplied by, because we moved it 2 places from the right to the left, to be multiplied by 10 to the power of 2 multiplied by 10 to the power of negative 7, right? So we're going to have this to be 1.54 multiplied by 10 to the power of 2 plus minus what? 7. So this is going to give us 1.54 multiplied by 10 to the power of 2 minus 7. And that will give us 1.54 multiplied by 10 to the power of negative 5. And that will be your solution. So you see, what we simply did is we just changed 154 to standard form, and it gave us 1.54 times 10 to the power of 2. We move the point from the right back to the left. And when you count from the right back to the left, you'll be counting what? Positive. And that is exactly what we get. So that is that. Now let's look at one final question before we'll now quickly round up this class. We're going to look at this. I want you to look at this. Most probably, I want you to simplify this, and then you tell us what your answer will be in standard form. I'll just drop this for you, and I want you to try it. And whatever your solution is in standard form, let us know in the comment section of this video. We're going to take it as a sample 2. And in that sample 2, we are given this. We are asked to simplify and express this in what? Standard form. That's sample 2. Let's consider that to be sample 2. In sample 2, we are asked to what? Simplify and express in standard form. And what are the values? We are given 0.00275 multiplied by 0.0064 divided by 0.025 multiplied by 0.0. So I want you to look at this question, try it, and then let us see your answer in the comment section. It's very easy as long as you can easily play around with it. Olakunle Jubri Okoyemi, don't forget to drop your question for me in the comment section. Or most probably, if you have the opportunity on any of my videos, just comment your question and I will be able to get an answer to your question. This question is on number basis, and most probably very soon we'll be looking at number basis. Now, according to your JAMB syllabus, we should be heading to the next question. The next topic we should be looking at is sword. So we'll be considering sword as we are taking the standard form. We'll be looking at sword operations. Then we'll look at some topics under number basis. We've already done number basis. That was the first class we did over online here. So I will look at your question, Okoyemi, and then we can discuss it together. The next question, the next topic we're going to look at is a topic under sword. And that is how far we can be able to go today. So today, we have under indices, logarithm, and sword. We have discussed the laws of indices. We've talked about standard form. We've talked about the laws of logarithm. And then we've seen how we can change bases in logarithms and their applications. And we've seen the relationship between logarithm and indices. So the next topic we're going to discuss about is sword. Don't forget to join us in our next class. And remember, if you subscribe, you are going to get a fast update of our online classes once we drop or make arrangements for them. Because of change in activities and schedules, I can't be specific enough to tell you this time is this time. So if you can be able to subscribe, once I set the time and the time frame, you'll get an update immediately about the class. This is how far we can go. In our next class, which is coming up soon, we are going to consider the use of English language. And we're going to see how to determine the topics in which questions in use of English are derived from. Don't miss that class. See you. Thanks so much for watching.